Okay, we've been working on this idea of looking at our systems and ultimately analyzing and designing our systems in a slightly different way. We've been looking at, instead of looking at the natural frequencies and its response to a step input like we did the first part of the class, we switched up and we are now saying, what happens if we subject the system to a sinusoidal input? What kind of output are we going to get? And the answer is a sinusoidal output, but it probably will be shifted in phase and magnitude. And then if we take that a little bit further to the next step and say, okay, well, we can calculate that at a specific frequency. What if we calculate it at a whole bunch of frequencies, actually all frequencies, and see how the system responds over the whole range, the whole gamut of frequencies? And then we can look at those places where it matches, the input and the output match, and we can say, oh, this is a good place for us to have control. We have control over these set of frequencies. Because if it's shifted in phase and magnitude, then it's not doing what we want it to do, and we don't have control over it. And so this helps us then to understand where we have control, and it also then helps us to start thinking about how we can modify the system to change that range, hopefully increase the frequency band to get better control over the system. So that's where we're headed with it. We've looked at being able to calculate these things, and now we want to think about what happens if how do we expand that and look at a whole range of frequencies? Well, there's a couple of things we could do. We could go in and calculate the magnitude and phase for a bunch of different frequencies and plot them, and then draw a line through them and have the Bode plots. Or we could write a little program to do that and have it loop through a bunch of frequencies and plot those out and give us a Bode. And both of those would be okay, but they're both brute force methods of solving the problem. And that's actually, the second one's probably what MATLAB does. They probably look at a bunch of frequencies and plot through them. But we're going to take a little bit different route because we want to be able to see this and understand it to a level where we can design for it. So just like we did with the root locus, we sketched the root locus, and then we could understand how to reshape the branches to get the closed loop poles to where we want. Now we're going to sketch the Bode, and with that we should be able to understand how to then modify it with our tools, our poles and zeros and gains, to get it to reshape to a different configuration, hopefully to improve the performance. So sketching the Bode is our next thing on our agenda, and we're going to use a technique called asymptotic sketch of the Bode. And so we'll be pursuing that. Now, another thing I want to mention is the scales on the Bode. We talked about this briefly in one of the lectures, but the x-axis is a logarithmic scale, and that's so we can see a broader range of frequencies. Okay, the y-axis on the magnitude is dB, or decibels. And this comes out of the communication arena, and actually it works pretty well, especially in our sketching. And you'll see why as we move through this. But we'll be mindful of that, because neither of those are units that we typically use in our analysis. We use frequency, we talk about in terms of radians per second, and frequency in the Bode is talking about in hertz. The magnitude we talk about as a raw number, just a magnitude, and you've got to do the conversion to dB. So be careful about both of those. We don't display them in the units that we work on them, so you're constantly having to do conversions between those, and so it will bite some of you, because I'll give you a frequency in hertz or in radians per second, and you'll need it in hertz, or you'll read it off the Bode in hertz and I'll want it in radians per second. And so be mindful of both of those, because they will be problematic in moving forward. And with that, let's get to sketching some Bodes.